This is the third toy model, and this model is identified. So here I can show you the intuition of identification. So now the difference here is the exogenous variables are different. x1 in the first equation and x2 in the second equation. Usually in economics, like if you think about demand and supply, if you assume demand and supply, then we call this demand shifter and x2 supply shifter. So something like that. It's a common assumption because this is identified. And now the exogenated assumptions are, there are 4 exogenated assumptions. And then you can now guess, okay, 4 assumptions for 4 parameters. Okay, it's good. And we may be able to identify them. By the way, I did not say that. As before, I'm assuming that the denominator is not 0. I will maintain the unique solution, unique equilibrium assumption throughout the chapter because it's obvious. Otherwise, nothing can be done. So even if I did not mention it in model number 2, still you have to think about that. So model number 3, we have now 2 endogenous variables, 2 exogenous variables, 4 parameters, 2 errors, and structural equations. And reduced form equations are now these. So y1 is a function of x1, x2, and errors. y2 is also another function of x1, x2, and errors. So we write pi11, pi12, pi21, pi22, which correspond to each of these coefficients. And the same rationale holds. You can identify pi11, pi12 because x1, x2 are exogenous. As long as they are not multicollinear, you can identify pi11, pi12. It's simple. So you identify 4 reduced form parameters. Reduced form parameters are identified, and you know the left hand side. These are known, and you'd like to recover beta 1, beta 2, gamma 1, gamma 2. How can you do that? If you can show, like say, suppose that you have numbers, you have results for these 4 left-hand side parameters, and then after some simple algebra, you can show gamma 1, gamma 2, beta 1, beta 2 can be written as functions of the reduced form parameters. So if you can estimate the reduced form, then you can recover the structural form parameters using this way, right? So it's identified. Of course, I assume that the denominator is non-zero, and then the denominator will be not 0. So there is no problem. So provided this is not 0, this is not 0. So denominator non-zero means beta 1 is not 0, beta 2 is not 0. So if beta 1 or beta 2 is 0, that means the exogenous variable disappears, which means you lose some of the exogenated assumptions. So if you assume that if you have beta 1 equals to 0, you lose 2 exogenated assumptions about x1, but you are still 3 parameters to identify. So you lose 2 exogenated and 1 parameter. It's unfair. You are losing more information than unknown parameters. So unless that's the case, if beta 1, beta 2 are not 0, then you can identify the structural parameters. And if you use the moment condition approach can be written in this way. So there are 4 moment restrictions, and then it looks like a huge matrix, but you can simplify this way. So intercept and parameters and matrix. So theta is a column vector of these 4 parameters, and the matrix can be written in this way. So the moment condition is, expected value of a and b, a minus expected b times theta equals to 0. And then it is simple to show that theta 0 equals to expected value of b inverse expected value of a. So as long as this is invariable, then theta is identified. Theta is identified, this is invariable, then just find the conditions for this to be invariable. This is the answer. So it's a mathematical derivation. So you can see that. So the left-hand side, so think about this. Left-hand side is the regression coefficient if you regress y2 on x1. And here, y2 is regressed on x1 using x2 as an instrument. So they should be different. If they are the same, there is some problem. I don't have a good intuition why this is related to the identification. I try to interpret this, but I did not get any satisfactory answer yet. So anyhow, up to this point, the mathematical intuition is clear. You just need invariability of this guy, right? And another approach is the IV approach. Here, the structural parameter, the structural form equation is understood as an IV regression, with this being the endogenous variable. And you need an instrument for this guy. That is, now go back to the structural form here. So think about the first equation. Y2 is endogenous. So you'd like to have an excluded instrument for this guy. Then look at the equation for y2. Here is an instrument you need. x2 is a perfect instrument because it is exogenous. It is not included in the first equation. So, and it determines it's correlated with y2 if beta 2 is not 0. So it will be a good instrument. So that is that's the intuition behind IV approach. So you may read, so if it's not 0, then everything will be nice and fine. Okay, so now, let me use the graph again. So what I explained is this. We want to have this kind of observation. We would like to identify equation 2. Then you have to observe like something like this. How can we do this? To do that, we have to have equation 1 moving like this. Equation 1 has to move has to slide down through the equation 2. How is it possible? So the point here is we have to move equation 1 without changing equation 2. Equation 2 does not change, but only equation 1 varies. The idea is the exogenous variables. The role of the point of the exogenous variables is, remember, demand shifter and supply shifter. So when x1 changes, only equation 1 moves. But when x2 changes, only equation 2 moves. So holding one constant and moving the other, changing the other, is possible. Like in this case, fix x2. By fixing x2, equation 2 will be fixed at this point. But now vary x1. By varying x1, you have different equation 1. So at each point, you have observed equilibrium like this. So connecting them will make the constant, the equation 2, which is fixed at the same spot. But if if there is an exogenous variable but they appear at the same time in both equations, it does not work because you cannot fix one and move the other. When you change x, both move at the same time, then the same problem arises. Like equation 1 and equation 2 moves at the same time, then it does not identify either equation. So this will be your result. Exactly same problem as before. So your observations, like by moving x, your observation is not from either equations. So there is no identification achieved. That is the intuition behind the simplest possible simultaneous equations model. So when you have two endogenous variables, this is the basic intuition, and you can imagine supply and demand example. Okay, I will call it a lecture. Thank you for watching. See you later. Bye.